All right, welcome to Earth Science Week 10. We're going to be talking about erosion and deposition. Last week we talked about weathering, how sediments are created from parent rock. Now we're going to talk about erosion, how those sediments are carried away, and deposition, how they are deposited in new locations. To submit, to show that you watched this recording, I'd like you to submit a little sort of spreadsheet to me. You don't have to submit a spreadsheet, but just your notes in this way. We're going to talk about 6 different types of erosion and deposition. Those: mass wasting, streams, glaciers, groundwater, waves, and wind. Basically 6 different ways that sediments are moved from one place to another. And I'd like you to write down whatever notes you want to write down as we're learning these things about erosion and deposition in these different contexts, and any keywords that might be helpful. There will be a lot of kind of new words for you this week. So the first type of mass wasting the first type of erosion and deposition is called mass wasting. And that's happening right here in what's called a landslide, as rocks are eroded, taken away from one area, and deposited in another. There are actually 4 types of mass wasting like this, and a landslide is just one of them. It happens to be the most destructive. You can see that one kind of depicted up here. Another one is a mud flow or debris flow, which is more of a, you can see rather than being sort of a rock fall, it's more of a liquefaction of silty material that then suddenly comes down a hillside. These two happen very quickly, landslides and mud flows. But there are also some slow processes of mass wasting: slumping, where you can see that a cliff side can kind of start to slump down layer over layer, and soil creep, where soil can slowly move rather than very quickly from its original location. And these are the 4 types of mass wasting that are eroding, taking sediment from one place and depositing it in another. What kinds of things do you think can trigger a landslide? Well, here's a list of them right here. Water saturation is one. In that first GIF image I showed you, it did look like everything was wet, right? The roads were wet, the rocks were wet. That probably played some role in loosening up or lubricating the landslide that took place. A loss of vegetative structure, roots and stuff, can hold soil in place. The erosion of the toe of a slope by water, or in that case by a road being paved through there, took out the toe of that slope, which made it more likely that a rockfall would occur above it. Then, of course, earthquakes. And you can imagine that earthquakes, as you recall, take place along plate boundaries, right? Well, interestingly, that's basically the same place where mountain building, or most mountain building, takes place. And because of that, there usually are a lot of steep slopes in areas where earthquakes occur, which makes it even more likely that there will be landslides and things like that occurring on a regular basis. But of course, mass wasting cannot occur in swamps. And why is that? Because mass wasting requires a slope. It requires a place over which gravity can exercise its power. So what we talked about there should give you some stuff to write in for describing erosion that takes place during mass wasting and deposition, and any keywords that you wanted to write down. We'll move on to the next one now, which is erosion and deposition by streams. So imagine you are a piece of rock floating, you might be a piece of rock that was released by a landslide, say, into a stream. Or you might be a piece of rock in your neighborhood, and a little speck of sand is broken off of one of these rocks perhaps and carried away into the stormwater drains or into the neighboring creek, and you're carried as part of that stream's load for a while. And it might take you a little ways and then deposit you, but it might pick you up again when the spring rains come and the stream is moving faster and carry you a little farther. And eventually you might find your way down a nice straight Usually steep slopes have straight river or straight streams going through them because they don't meander much through that area. You might be part of a tributary, which is a small river that joins with a bigger river. And as you move down into the valley, you might find that your path begins to meander more. We actually literally call those meanders as the S curves are created in that area. And then, of course, oxbows, like here where you can see that the water used to go this way, but then it actually cut itself off and came through at a faster way, and it left this oxbow behind, and eventually even can be an oxbow lake when it all fills in and the path rejoins there. And eventually you would be flung out, well, maybe once you came down the steep hillside, you might first end up in an alluvial fan like this. Alluvial fan, Alluvial. Here's an aerial view of one. But you might be eventually you'll be picked up even from that alluvial fan, maybe during a flood or something else, and carried out to perhaps a wide meandering river, and eventually out to the mouth of that river, to the delta. And that's how erosion takes place, by streams and rivers, and then eventually that deposition at the mouth of the river. You're going to see there's usually deposits that the river will make its way through, where the river meets the ocean at the mouth. Erosion can also take place by glaciers.
It's 1330.
They basically do the same thing, only much more slowly. And they also form, they have a form that's sort of recognizable. You can almost tell by looking at it that this valley was formed not by a river, but by a glacier. There's something about the shape of it, kind of V-shaped and maybe very rounded at the bottom, that doesn't really look like a river valley, although I'm sure water flows through it now. But it was carved originally by a glacier. These are the Cairngorms in Scotland. You can see a glacier here in the Himalayas. It's slowly making its way down and then melting into that body of water. And here's Elephant Foot Glacier in Greenland. And here is one in Colorado. So you can imagine a glacier is going to pick up rocks, debris, sediment, carry it with it. So it's eroding that stuff away from where it was originally weathered. And then it's going to deposit it. And some of the landforms we see when that sediment is deposited are moraines. So till is anything that a glacier picks up and carries, any rocks that a glacier picks up and carries. And it usually sets down that till in particular patterns. And you can see some ridges here, like down along this area, there's a ridge and another ridge, where the till is sort of piled up in a long ridge called a moraine. You might want to write those down. This is deposition now by glaciers, our third type of erosion and deposition. You can also see a moraine way up here, right? That might even be the height of where the glacier went, and it was sort of pushing rock up against the side as it went down. So these are features that we see after a glacier has passed and disappeared. Another type of feature that we can see are kettles, which are tiny little lakes that occur in usually flat areas where a glacier once happened. So as a glacier retreats, maybe because of warming temperatures or something like that, it might leave behind a couple large chunks of ice that don't melt as quickly, or perhaps are covered in such a way that they don't heat up and they might stay cold enough. And they might eventually be covered by sediment that's washed away from the glacier, washing around those big blocks of ice. And once the ice eventually does melt, it can leave behind basically this depression in the ground. It's nice and round, and it's this tiny little cute kettle lake. And that is a way, another landform that's left behind by glaciers. Now, it's not really that the deposition is not the deposition of the ice, but it's the deposition of all the sediment around the ice that creates this sort of unique feature. In fact, you could say the deposition is actually taking place here by streams that are carrying this load down around the ice as the glacier is melting. Well, question, do all glaciers erode the landscape? You might think, well, of course they do. Glaciers have to move even though they move slowly, so they're eroding, they're carrying stuff with them, right? Well, not true. There are glaciers that are basically on flat ground. So just like a swamp is not a place where mass wasting can take place, or where rivers can carry a load because it's just stagnant water, sediment will not be moved around much in those conditions. The same is true of continental glaciers. And interestingly, there is an enormous continental glacier at the South Pole. It's called the East Antarctic Ice Sheet, which is by far the largest glacier in the world. It makes up most of Antarctica, and it gets up to 3 miles deep. And it's about the same size as the United States, the continental United States. So imagine from Oregon to New York City, buried in ice 3 miles deep. That's what you have down in Antarctica. And you can imagine how much water then is locked up in that East Antarctic Ice Sheet, which is down below here. Pretty incredible, right? And there's no erosion or deposition taking place, but I bring this up just because you want to be aware of the different types of glaciers that exist in the world. And most of it is just a flat, barren ice desert. Crazy, right? You could dig down 3 miles and you'd still be in ice. Question: how high do you think the oceans would rise if all the glaciers in the world melted? You could write this down. I know that I'm only asking you to take notes on these particular things we're discussing. Right now we're down on glaciers. But you could write down how high you think oceans would rise if the East Antarctic Ice Sheet and the other littler ones like in Antarctica and Greenland were to melt, and the glaciers that are on mountains and stuff like that. If they melted, how high would the oceans rise? What do you think? Well, the people at National Geographic have figured this out, and I don't know when this was, September 2013, I guess, based on the thermal expansion of water and the melting of all that ice, etc., they believe that it would rise about to the Statue of Liberty's waist, which is crazy, right? Statue of Liberty there in New York Harbor, 214 feet above mean sea level. That's a big change. Luckily, we haven't seen any melting of the Antarctic ice yet with global temperatures warming, but that is something that will eventually probably happen as we're moving in this warming trend. All right. Well, the fourth type of erosion that can take place is by groundwater. And groundwater can erode especially limestone, as you might remember from before, by dissolving it, right? As water runs over it, it can dissolve the limestone and then deposit it somewhere else as it cools down and can't hold as much load or whatever it might be. The little minerals will come out of solution and create perhaps a stalactite or stalagmite. And that's how caves develop, like these cave systems that develop in limestone areas, karst landscapes, where water can pour down into these caves, creating cenotes, as you may think we maybe talked about. In Mexico is where that's common, the Yucatan Peninsula, but lots of other places as well. And even, what looks like a great place to play golf, right? You got lots of little pot bunkers or whatever. Fill them up with sand, etc., etc. Of course, there is danger always in these karst landscapes of there being a collapse or a sinkhole or something like that, because there's a lot of caves beneath the surface. So groundwater can cause erosion. Waves can cause erosion and deposition. And in this case, the main type of erosion we're dealing with, of course, has to do with sand. You can imagine, you can kind of see some of the cool features that are created here by the erosion of waves against these rocks. And we're kind of getting now, these last two types of erosion and deposition don't really require gravity to function. The rest of them kind of require gravity to basically take rocks and minerals and sediments downhill. But in this case, we're not dealing with gravity anymore. So how does ocean erosion and deposition, or wave erosion and deposition, take place? Well, if you've noticed, if you've gone down the Oregon coast, the highway is windy, right? The coast is not just a straight line. The coast has headlands that stick out like this, and then it has beaches where the sand is deposited on the interior. And this is true of oceans around the world. Because as waves strike the shore, no matter how straight it might start out as, there might be a tiny bit of it that's pointing out a little bit, and waves are going to then be deflected. And as a wave approaches, let's say, as a wave approaches, you can imagine it approaching this headland here, it's going to be deflected to the left and to the right. It's not going to release the full force of those waves on these rocks themselves, usually. And that it's going to be deflected and the full force of the waves is going to be felt more to the sides of these headlands. And so the headlands can stay out pretty far, experiencing a little bit less erosion than these parts to the side. And the sand then can be carried by these waves and deposited in different areas. So generally, as this rock is weathered, the erosion can carry stuff from the headlands into these beach areas. And as they do that, as they strike the shoreline, they can create some different features, like a sea arch. You can see one here. Or eventually a sea arch that may collapse, and all you're left with is a sea stack and the headland itself without an arch. The sand, of course, is carried in this interior part. And if the waves are striking a particular bit of coastline at an angle, they can actually start to deposit sand out on something called a spit. So if the waves are approaching from left to right here and sort of breaking on the ocean like that, they're going to begin to push the sand out, and they can create a spit like this of land out beyond where the original shoreline was or the sand was deposited. And that can create things also like barrier islands and a baymouth bar. So we call this longshore drift the fact that sand or sediments can be moved, they can sort of drift along the ocean as the waves strike, if they're consistently striking a particular bit of shoreline at an angle. And they're going to push the sand down the beach to the right or down the beach to the left, depending on which angle the prevailing waves come from. So let's look at some of those examples, and we'll call this a quiz, but it'll kind of just be a bunch of examples. So here you can see that a bunch of sand here has kind of accumulated and been pushed down out into this peninsula area. And so the waves must be striking the beach from the left to the right to be pushing the sand out here. That's exactly what's happening. It's creating, these are the different options we basically have right now. It's creating a spit, and this is called Homer Spit in Alaska, a sand spit produced by longshore drift. So it is evidence of longshore drift also, as the sand has been moved from its original location. Here's another one. Humans have actually put up these fences here to try to stop longshore drift, and you can see that they don't always work. So these waves, the prevailing waves, are always striking the beach from this side and pushing the sand to the right, which means it's eroding sand away from here and pushing them up against, in this case, it would be the next bit of wood that's there. And we're sort of futilely trying to hold back the sand by putting these walls up to keep the sand from being eroded away from the beach. But it's just going to be eroded to a new place where it's going to create more beach. But if this happens to be your beach, you don't want that to happen, right? You want sand on your beach. At least most people do. So we would call that evidence of longshore drift. Next one, you can see we have some various things. We have some sand bars underneath the water here, as well as some barrier islands out here that are created as the waves break from far in the distance into this area. I think this is the Outer Banks in North Carolina. And this, you should recognize, this is a sea stack, and specifically we call it haystack rock. If you've been to Cannon Beach, you've seen this. Sorry for the grainy picture. So it used to be part of a headland kind of like this. This is a famous sea arch in Cabo San Lucas, and you can imagine that eventually that arch will collapse as this is eroded away, and we'll be left with a sea stack out here of some kind. And lastly, we might have here in, I think this is in Florida, I'm not actually sure of that though, a barrier beach, where you eventually get sandbars that grow so large that they become beaches on their own, that are sort of out from shore. This is very true in Florida, where they actually have lots of barrier beaches like this, some of which, like Palm Beach, for example, or West Palm Beach, or I guess Palm Beach, is basically built on barrier beaches. And they've built an intercoastal waterway where boats can basically navigate through between the barrier beach and the mainland of Florida through large swaths of the Florida coast without even having to go out to sea, because they're protected by these barrier islands, which are quite large in Florida. All right, the last type of erosion and deposition that we will talk about is wind erosion and deposition. This is Mingshishan, known as Singing Sand Mountain, a major stop on the Silk Road in China. And it's kind of a beautiful and really interesting location there, isn't it? With these huge sand dunes around it. Well, how do those sand dunes form? Well, they formed because of wind deposition. So, of course, you can imagine if wind blows along even a flat sandy beach, and you see this on beaches because there's usually undulating sort of waves of sand that are created by the wind blowing on it. That if the prevailing winds are coming from a particular direction, they're going to carry along sand grains by saltation, which causes the sand just to sort of move a little bit. It's not actually sort of picked up, but it's causing the grains of sand to move along the beach. And they'll build up into piles, and as a little bit of a pile forms, more sand will want to sort of accumulate there, and that'll create a steeper and steeper slope. So it starts with deflation. That's what we call it when wind picks up sediment. Sorry, just wind. And then deposition, as that sediment piles up in a particular area. And it's deposited further as that dune begins to grow. So that is how sediments are deposited and sand dunes are created. So anytime you see a sand dune, you usually see a shallow slope like this that tells you which direction the wind is coming from, and then a steeper slope, which is going to tell you that's the way the wind is, the wind is going over the mountain, and the steeper slope is on the back end of the dune. And then, of course, wind can cause weathering and erosion and deposition all at the same time. So why do you think this rock has a funky shape? Well, it's because if you ever noticed, if you're at the beach and you're laying down on the beach sometimes and it's windy, the sand will be blowing all over your face and you can't see anything. It's kind of annoying. But if you just sit up or stand up and get enough above the surface, there will be no more sand except for down at your feet, because the sand doesn't get carried high into the air usually. And so you can imagine that if you have prevailing winds that are carrying sand a lot by deflation, picking up the carrying of sand, or saltation, causing the sand just to jump in little jumps, that sand is going to hit against rocks. And this is an example of that happening, so that this rock was eroded way down at the sand level down here, but not much sand was striking the top of this rock, and so this part didn't erode and it still sort of exists, and luckily hasn't yet toppled over. So you could have, if there's a rainstorm out here, you could have a nice shelter for the night, but you might want to be careful that thing doesn't fall on you. So deflation, sand is picked up, and it creates abrasion or weathering, abrasion being a particular type of weathering that's going to weather this rock. There's a better picture of it if you want to see it. All right, that's it for today. So you should have a little bit of information that you can write down on each of these 6 types of erosion and deposition, just describing how mass wasting does some erosion, how it contributes to deposition, how streams erode and deposit sediments, how glaciers erode and deposit sediments, etc., etc. And if you send that to me, then you will get credit for your participation for this week. Thanks, guys. Bye.